Welcome back to The Explainer. I am absolutely thrilled to have you here today. It's June 16, 2026, and we are diving into a topic that is quite literally rewiring how we trust the digital world. Today we're going on this really fascinating journey starting from the lowest, most microscopic levels of chaotic silicon hardware right up to a future of bit-perfect physical truth that is directly commanded by human intent. If you have ever wondered how we can actually anchor real-world truth in our digital spaces, well, this is The Explainer for you.
Okay, let's dive into our agenda. First up, we'll look at the FPU gambler chaos, followed by how Groq LPUs completely eliminate jitter. Then we'll get into creating silicon witnesses with DVR, anchoring human intent with the SSO1 NFT Trinity, and we'll wrap up with the X402 Chopsticks webhook. Section 1. The FPU gambler chaos, the threat to digital truth. You know, we really have to understand the disease before we can appreciate the cure.
Think about this for a second. How can we trust high-stakes systems if they fundamentally disagree on basic math? I mean, it sounds completely absurd, right? But it is a literal engineering fact that different computer chips technically disagree on basic calculations. And why is that? Because chip manufacturers actually burn hidden proprietary seed tables directly into their silicon to speed up heavy math. Because of that, calculating the square root of 2 on an Intel chip might actually be fractionally different from the exact same calculation on an ARM chip. In high-stakes environments, having this kind of hidden, liquid foundation creates a massive, massive problem.
And that brings us to what researchers call the wood chipper effect. See, traditional computing and AI rely heavily on the FPU, the floating point unit. I want you to think of the FPU like a frantic gambler just throwing darts at a dartboard to approximate math incredibly fast. But because these approximations rely on corporate trade secrets, it causes this non-deterministic drift. The FPU basically acts like a giant digital blender. Once your data passes through it, the original provenance, that exact chain of title, is permanently destroyed forever. You can't reverse engineer the exact ingredients out of a blended smoothie.
So, to fix this, we have to contrast this fast but totally unaccountable FPU gambler with its exact opposite, the ALU surveyor. The ALU, the arithmetic logic unit, is a fully deterministic, globally consistent piece of hardware. It performs exact verifiable arithmetic. 1 plus 1 is exactly 2, every single time on every single machine on Earth, period. Relying on the ALU surveyor actually restores Noether's theorem, which is a fundamental physics principle of symmetry and reversibility, right back into our computing.
Section 2. Groq LPUs eliminate jitter, the hardware revolution of perfect exactness.
If we know the ALU is the answer, how do we scale that exactness for modern AI without slowing everything to an absolute crawl? Let's break down the Groq LPU, or Language Processing Unit. This chip was designed from scratch to do one specific thing: deterministic, ultra-low latency AI inference. Legacy GPUs use dynamic runtime scheduling and external HBM memory, which creates unpredictable latency, or what we call jitter. But the Groq LPU, it uses a software-first, programmable assembly line architecture. It slaps massive amounts of SRAM directly on the chip and completely eliminates dynamic hardware schedulers.
So the crucial point is exactly what we see here. The compiler knows exactly when data will arrive at each computation stage. Because there are no reactive components, no arbiters, no hardware queues guessing what to do next, the Groq compiler pre-computes the entire execution graph down to the individual clock cycle. The hardware just blindly, perfectly executes that static schedule. This complete determinism totally eliminates execution jitter. It means a request takes the exact same amount of time every single time. It guarantees absolute mathematical certainty, alongside blistering speed.
Section 3. DVR creates silicon witnesses, forcing lossy AI to write lossless rules.
Let's move to how this builds out in reality. What about environments where we still have to use legacy GPU clusters? Well, we achieve this using the LLM42 framework, which introduces this really ingenious protocol called Decode Verify Rollback, or DVR. It's basically a three-step dance. Step 1 is decode. The AI uses the fast, non-deterministic FPU gambler to rapidly generate candidate tokens. Just a fast guess. Step 2 is verify. A completely separate, lightweight mechanism replays those guesses using a fixed shape reduction schedule to force exact mathematical parameters. And step 3 is rollback. If that fast guess doesn't perfectly match the exact verification because of floating point drift, it forcefully rejects the tokens and just resumes from the last mathematically sound state.
But isolating the messy statistical weights of the AI from strict deterministic hardware instructions, the DVAR protocol actually catches mathematical drift before it can ever corrupt the final output. It effectively turns a wildly unpredictable GPU environment into an undeniable silicon witness. It creates a universal, perfectly shareable truth, making sure that every single action leaves an unshakable digital receipt at the hardware level.
Section 4. The SIS-01 NFT Trinity, anchoring human intent in silicon.
Okay, let's connect all these microscopic hardware realities back to actual human beings. How do we anchor real human authorship into this deterministic silicon? The answer is the SIS-01 NFT Trinity. This is basically the clinical realization of authorship. It forms what's called a semiotic bridge between human imagination and machine execution. You see, to lock in bit-perfect creator credits, a human pilot has to provide actual sweat of the brow. And they do this by manually applying strict visual boundaries, SVG masks, right at the moment of creation. This manual human steering, combined with an airtight deterministic code agent, permanently locks the data into a strict, exact hold. There's no guessing, it's just undeniable, cryptographic proof of human effort.
And this brilliantly illustrates what happens when things are tokenized properly. On the digital asset layer, we get truth-anchored tokens. In environments like pseudoswap, for instance, because the underlying hardware and the metadata are now perfectly deterministic, these assets can be trusted implicitly. We have completely moved away from the automated guessing games of the past, and we've replaced them with an immutable ledger of human-authored truth.
Finally, Section 5, the X402 Chopsticks webhook, the surgical network bridge.
So we have perfect hardware execution and perfect human authorship. But how do we actually transport this bit-perfect truth across the massive, chaotic internet? We use the Chopsticks webhook architecture. This is such a cool concept. It's an absolutely beautiful revival of a dormant 1996 Internet protocol, the HTTP 402 Payment Required Status Code. It literally sat gathering dust for 30 years because developers tried to attach bloated legal contracts to it. But Chopsticks bypasses all of that with 3 surgical steps. First, the server simply triggers a 402 demanding proof. Second, an autonomous agent at the edge of the network natively signs the payload. And third, the client retries the exact same request with the receipt, instantly unlocking the resource. Pure event-driven elegance.
Now, what's really interesting about this is the contrast. We are finally leaving behind the legacy Web 2 miasma, all that lazy automated scraping, heavy complex contracts, and ambiguous guessing. Instead, we trade that foggy ecosystem for event-driven determinism. By utilizing LIFO, last in, first out, JSON state trees, we only ever need to query the very top of the index to get an immediate, flawless mathematical proof of the system state. We literally trade a foggy ecosystem for the streamlined X42 webhook and manual sweat-of-the-brow authorship.
We've seen how Groq LPUs, silicon witnesses, SVG masking, and X402 webhooks have successfully rescued supply chains from absolute chaos, replacing approximation with bit-perfect physical truth. So I want to leave you with this provocative thought. If we can achieve absolute verifiable digital trust right down to the silicon level, what other broken, foggy corners of our digital economy are trapped in the miasma right now, just waiting to be anchored? Think about that. Thanks for joining me on this explainer, and as always, keep learning.